So the topic of tonight's talk is API clients. We're going to start with a little front matter as we need to. My name is Ben Lopatin. I'm Benny Lope on the internets. I'm a partner, co-founder, and developer at Well Interactive, which is a custom web application shop. This talk was a talk I gave a few weeks ago in Nashville at PyTennessee. So there is a little bit of Python in the talk, but the talk really isn't a Python talk. These are just examples. And where I do use Python examples, either code or libraries, I'll make references to non-Python examples, and really they're just the example. So I'll make sure to explain to you that. We're going to have time for questions afterwards, but if you do have a burning question in the middle, feel free to raise your hand and ask. If it's a question in anger, save it for the end. That's all I ask. So let's set the context here. What we're talking about today is clients, not services. When we talk about an API, we usually mean the service, right? There's a web server, and it runs a service that we get data from. So why are we talking about clients? I think it's really important to start with the why. And the API, the service, gets all the love. Basically, we talk about how do you design. What's the shape going to look like? What are the resources going to be? There's a lot of thought put into this, but at the end of the day, that's really only one half of the story. Okay? The API itself is useless without people or entities talking to it. Okay? And those are the clients. So it's nice, it's necessary, but it's insufficient. What you get is this. One person, you can't play tennis by yourself. You need to have two people. Okay? I'm going to talk to you a little bit about aspects of design, about logging and testing. This is not the sole way of doing this. Okay, these are some good ideas. A lot of this is kind of notes to myself from having worked with different libraries, different APIs, and writing some clients and using it with those clients. And what did I see that worked well? What did I see that could be done differently? What was really useful? What do I wish I had known earlier? So they are, to that extent, they're best practices, but that's the extent to which they are. Right? The first thing I want you to take away is that when you are writing a client, when you're designing this client, you are making design decisions. I think it's easy to fall into the trap that there is this API service, and we're just kind of writing a wrapper around it in whatever programming language you want to use. But there's more to it than that, and so whatever you do, you are making design decisions, whether they're explicit or not. So let's get over some of the assumptions in this talk. Talking about RESTful APIs, talking about JSON, probably. Again, much like I'm using Python examples at times, those aren't necessary. Okay, your API could be doesn't have to be RESTful, doesn't have to be using JSON. Those are just some of the things you might be talking about as examples. The first thing I want to discuss is the data model. This is something we're looking at in an abstract sense. And again, the question why. Why do we bother talking about the data model? Well, with an API, we've got several things here. We've got the API itself, which is a service layer. We've got a database. We've got the real world. What we have is layers of abstraction. It is layers of abstraction all the way down. But at some point, it's important to kind of understand what you're dealing with, how the user is going to be consuming this data, and how best to represent it. Just because the data is represented in one way on the service doesn't mean that's how you want to use it on the client. Okay? So you want to make sense of this. You are abstracting connections and data. Right? That's one of the biggest things to think about. Well, it's just a way of connecting to the API. You're using some sort of library, an HTTP library, a networking library, and that makes it easy to get the data. But you're also pulling in the data itself. And you're going to be transferring that in some way in a language. So you do want to give some thought to this. In Python, there's a few ways you might do this, and probably just skip ahead to the code here and show you. This probably looks fairly familiar to anyone, even if you haven't done any Python work. We've got a class, and in the constructor here, we are assigning some values to attributes on the class. Right? It's a fairly standard. There shouldn't be anything really complicated about this. And Python, notice here, we don't have any getters or setters, so we just access the attribute. Another way you could do it is just by having a map type. This is, if this were JSON, we could just serialize a JSON object into this type right here. And then we can just pull it out as as a map, a dictionary here, whatever you're going to call it in language. And I'll get to some of the reasons why you might do one or the other with performance. But even though it's really doing the same things, you're going to interact with it in a different way. So there's some design considerations that come into play here with the data model. And then you might want to apply some methods to it as well. So it's not just data. So in this case, we could just take what's a dictionary, and it's basically the native type in Python, and we just add some attribute methods to it. That's not going to be the same impact in every language. Okay? And I think I'll be able to explain this better when we talk about performance. If you're doing this in JavaScript, you're probably just going to have the object. If you're doing this in Go, you might decide that you really want to declare these individually rather than just this abstract interface. The other consideration is whether you're working with data or resources. And it sounds kind of like a silly question when I say it out loud. Every time I think this is a silly question. What it means is that some APIs are really representing resources, and some are really representing just data. An example of this is a geocoding API. What are you getting out of this? You're sending it an address, saying, here's my query, send me some results back. But that doesn't really represent a resource in the system. Whereas if you're looking at something like maybe the Facebook API, you're pulling back all of these resources, okay? And they, a profile, there's friendships, these things all related to each other, and you might want to represent them that way. And you should also be mindful of what you discard. When I showed you this here, if we were getting data from directly from the service, we're just taking this JSON, just turning it into a dictionary, we could just be taking whatever they give us, for better or for worse. Whereas if we define here, we say, here's my resource, here's my object, and I'm just going to have these elements on it, you're stuck with those. The benefit comes into play occasionally. The instance here I was working with an API, it's a geocoding API, and I wanted to make a really simple client, so I just used the dictionary, associative array, a hash, a map, and when they changed the service, when they started providing extra data, I basically got it for free. I didn't have to do anything extra to get it. I just said, okay, let me just add this extra field for querying it, and it's available anyway. So you have to consider how you're using this, what kind of data, how it might change, and maybe who's using it as well. So that's the data model. Let's talk about everyone's favorite. You guys probably don't know about this because you haven't had to deal with it, but it's errors. You guys are all phenomenal. Never had to deal with this issue. This is, by the way, this is Richmond Airport. This is in Tennessee, Nashville Airport. Not the same trip. I have a collection of these blue screens and stuff from public displays. So again, the question of why. The short answer is I don't know why things fail. I don't know why there are errors. There just are. Maybe we can answer the question of what. What are we talking about when we talk about these errors? They come in a number of, we can see a number of these errors. We can see application errors. There's a problem in that application, it's returning a 500 error. They could be authentication errors, account errors. You reached your cap. They just be connection errors. Okay? What we want to be able to do is either recover from these or be able to somehow give some information to the user or ourselves about what happened. So now we want to know what's the way that we do this. I'm going to suggest exceptions for the reason I think these give you a really explicit, obvious way of dealing with flow control error. And so what this looks like is you have this, our client, which is abstract what we're doing, and the client raises an API payment error. We can handle that. Whatever we want to do here, we could say, we're emailing corporate accounts payable, or maybe it's an authentication error. In each of those cases, there's a specific thing we want to do in the application to respond to it. And so it's really easy to kind of just identify that. You look at the code, you know exactly what's happening. You don't have to know what the status code is or anything else like that underneath there. In many cases, it's really easy to do just by mapping exceptions to API errors. A lot of APIs will provide the kind of a list of expected status codes. Hopefully it's 200, you might have 400 errors, 300 errors, telling you kind of what happened and what their specific reason is for doing that error. And so you can just map these here. So we've got, don't press stop. Great. We've got bad input, that's a 400. We've got 401 error. And so each of these exceptions can be handled very explicitly in the code without kind of reference to what's going on underneath. And I said map them. Again, we've got a map, dictionary, associative array with the error codes and just with the exception here, and that can be very useful just in your error handling code. So we've got, in this example, kind of one exception per error code. Here's the list of error codes from Ippon. There's 92 of them. How many of you want to deal with the 92 exceptions? I don't think so. So we probably wouldn't do this for all error types here. What we might do, though, mix these up. And the other thing is that these errors aren't necessarily limited to the status codes as well. You could get in error codes for a 200 response. So the suggestion here would be to mix error codes and exceptions. We have an exception, and the exception takes an error code. We can still group these by type. So you know this was an authentication-related error. It was an account-related code, and you can still respond to that in your code base, and capture the code for whatever other purpose you have. Where you do this is, whenever you're responding to the making a request. But ultimately, what you're doing is you're just trying to make these exceptions available to the user of your library. Maybe that's you, but in the code outside of the client. And I didn't really cover it here, but something I thought was worth touching on was retrying requests. This is typically not going to be in response to, let's say, an authentication error. There's no point in retrying if you have an authentication error. But if you have a connection error, even a server error sometimes, these are worth giving a few retries just to see if you can get a successful response. So we've talked about the data model, and we figured out now that we have to deal with errors. And the question now is, what do we do when we have errors? How do we know that we got them? And the answer is to log them. Right? This is, I think, one of the most valuable tools found in working with any API, deploying a client, is to make sure you're logging. Why? Sorry, I asked this question a lot. I don't even have kids. The reason is we need to do some debugging. We need to know what's going on. Often you're going to have this code deployed somewhere. So if you're just interacting, let's say, with this client on the command line, you're going to see the errors. It's fine. You can see what's going on. You have this deployed in an application somewhere, and you have your own customers. And they come to you and they say, I've had some problems doing X, doing Y. You say, oh, it's funny. Seems fine. We haven't had any errors. And you realize it might be the API. So you talk to the vendor, and they say, no, everything's cool with us. And now you don't know. So logging gives you that information. And it's probably saved one or two of my customers. What do you log? Like this question, too. A few of the things you want to do is verify just the requests were issued. That's just really helpful to know. Can you count these? In many cases, you're dealing with a cap, or you want to be able to count how many types of response went out for a certain type of request. Looking at API performance. This is important even if you don't own the API, because it impacts your application and it impacts your customers. And it's really helpful, again, working with the vendor, if you are working with an individual vendor. And that's where API errors come in as well. Be able to alert the vendor, like, look, this is what we've been dealing with here, and they can look at their logs and verify. So how? This is pretty straightforward. I think it's going to be based on the whatever framework you're using, your language. This is a pretty straightforward Python example. We have a function here, a method, that basically makes a request. It sets some headers, a key, and calls the request library. One thing you'll notice up here is that we have a Python decorator, which is just, it's functional composition. It's not a really good Java syntax. And this automatically logs requests for us. So here's what it looks like, and it's not important. Again, the Python here is not important. What's important is this, that we're taking whatever function we had here, which is the column function. We're trying to get a response. If we don't, we're going to log the error. And if we do, we're going to log what happened here. So in this is, again, kind of a trivial example. Just what was the status code? How long did it take? What URL did we hit? What was the method? That's it. And then we just return the response. So now you have this history you can go through and look at, how is this API performing, what was happening, and what kind of errors did we see. So we've talked about the data model. We've talked about errors. Ideally, we want to avoid as many errors as we can. We can't avoid errors that happen because of the network that much. We certainly can't avoid any errors that happen because of the service. But we can avoid errors in the client. Why? Measure under the screen. This is what we want to avoid here. So how do you test an API client? There's a few ways you can do that. You could just test against the live API. You could use mock servers. You could just mock your responses. So let's go through these one by one. What about testing live? This is probably the first way that anyone looks at testing their API client. And it seems sensible, right? Because you want to see that this works against the API. If you do any kind of web application work, you probably test an ORM and you might hit the database. So why not hit this service? It's not nice. If you're working with someone else, you're making all these requests against your API, and it's also not fun. You need to be authenticating to this API every time you do that. That means you need to be managing these keys for your team, for your server. If you have other people using this library, you want to be able to let them test it. Now they have to set this up themselves too. So it's going to be slow and it requires an internet connection, which I don't like either of those. So I think we're going to say that even if we've got a sandbox environment, not production, we're not going to do this. So how about a mock server? This would be kind of your own version of the API server you set up, maybe one in parallel with your test group. It's another service to manage though, and if you already know enough to set up this mock server, why not just kind of mock these responses in your code? So let's forget that. Let's just mock everything. So how do we go about this? What do we mock? We're just going to be mocking requests and responses. These are some background libraries, and again, you don't need to worry about these exactly. But the first is we have a general mocking library, so you can just mock any of this stuff yourself. Then we can also use kind of framework-oriented libraries. We're actually going to mock. They're going to work in a specific HTTP library and mock the entire workflow. If you've done any Ruby work, you might have heard of VCR, and Betamax is very similar. They have nothing to do with seeing videos. The way they both work is that you basically have all the requests you want to make, and you're targeting the live server, the live API. And when you issue these requests, they store the responses as fixtures. So the first time you run them, you're actually doing the API, and then every time you run it afterwards, you've got fixtures instead of mock data. There are some pros and cons of this that I will get to shortly, but they're all basically allowing you to, when you're running the test at some point, fake what you're getting from the server. So when we test it, all I have to do is say, here's my test. If I assert that I'm getting this error, and I'm going to issue this post request to this address, and I'm faking it, and when the status is forward to, make sure I get this error. It's a really simple test, but at this point we can basically make what looks like a call to the endpoint, but we never do. And another library here. The nice thing about doing this method, or just mocking yourself, is that What happens when you get to a 500 error? How do you deal with that? If you're using something like Betamax or VCR, so you know I'm just going to get fixtures for these responses. And so you get a 200 response, or you get a 404 response. How do you do it with a 500 response? Or a 504 response? When you just flood the service with requests and say, you know, I'm going to take it down, and I'm going to get that response back and use it in a fixture log. That's not a good way to win friends and influence people. So I suggest not doing that. And that's where, at the very least, you want to be mocking part of your test suite. And that doesn't mean that all live testing is bad. There are instances where you want to do some, I think, or to warrant it, not as part of your normal test suite, but to kind of run in parallel. So this is, don't worry about reading this text here. This is the Census API, and there was an instance with a customer where they were hitting the Census API, and all of a sudden they noticed that data wasn't updated on their site, where they were getting this data from. And they said, we don't know why. And we looked, and it turned out that the Census had changed their API. They didn't have a contract for their API. And there was no way to know ahead of time. But if we'd been doing any kind of live testing, it would be really easy to find out. So just sort of a task to do a sanity run. Does this API kind of do these things and respond in the way that we expect it to? So we kind of thought of the data model. We have looked at some of the errors we might get, figured out how to test for them. Now we want to make sure that the client library works well. So we want to start being a little bit concerned about performance. This, I think, is kind of, it seems counterintuitive. Why would you worry about performance as the API's responsibility? That's what should be quick, right? The client just consumes this. But in fact, the client has a lot of influence over the perception, at least performance for the end user. So the first thing you're going to want to do is make sure that the client is taking care of connections. Very likely this is going to be handled in whatever framework or library you're using to connect. So in Python, that's going to be request or URL lib 3, pooling connections. So you're making multiple requests, that you're managing a session and not creating a new session for every single request. You also want to batch requests where you can. If you're working with one of these, an API, geocoding API is a great example, where you can send multiple addresses and get responses back. You could make a request for a single address, or you could just batch it. They'll let you send so many at a time, and you batch all these requests. So the client library needs to ensure that just because the API supports it, the library does as well. And using the right methods that the API exposes. If it's a resource-oriented library or API, you can get a single resource and get this one at a time, perhaps. Or you could do a search. So Zendesk was an API that does this, where you can think of it like a select query. Basically, you get all tickets that match this, and your query will get all of these tickets, rather than having to do some sort of request based on the IDs that you have. And the other is data structures. And this is a little bit more Python specific, but I think it's applicable to any language here. In the original example, I showed you something that looked like this. So this is our class here. What happens in a Python interpreter, when you create the class, what it does is it uses a dictionary and a map associated array. It creates this automatically, and that's where it stores these attributes. That's actually somewhat memory expensive. It's really helpful because you can store whatever you want, you can choose attributes as you go. So what you can do instead is just tell it, here are the attributes I want to use. It won't create that dictionary. It'll create these attributes, and you've just saved potentially 40%, even more, I think, sometimes in the wild, of your memory usage. So again, this is going to vary a lot by language, but you do want to be a little bit concerned about how you store this data. And this is probably a little bit more obvious, and this is concurrency. If you have the opportunity to make a lot of requests that are all very similar, do you have to make them serially, or can you kind of send a bunch at once? I don't want to spend too much time here, but we can basically take a bunch of our data and we can map it out. So we can chunk it, and then get a whole bunch of lists of these, and then send these out 5 at a time or so, 10 at a time, however many you want to do without saturating the API. And that'll gain us maybe a fifth of the time, because we're able to send out send these out in chunks like this at the same time. So let's recap again. I should have you guys recap to see if you're following along. We're presenting the data model, errors, testing, performance, and we also want to make sure that it's reasonably secure. Here, I'm going to punt. I'm going to say that this is mostly the concern of the API, but there are a few things the client can do. One is make sure it's using a secure protocol. The other thing you might do here is make sure that you're checking certificates if you need to. And then making authentication simple for the user of the client. The one thing I've seen with only a few libraries is sometimes really being very opinionated about how they take in the credentials. So it's kind of irrelevant what the API service is doing. You want to let the end user of the client library provide those credentials however they want to, rather than say by default looking at one configuration file that only taking them from the environment. Documentation. I'm a big fan of documentation, and this is where I think, if nothing else, a good README is helpful. But this is where I'm actually one of README-driven development, because in the client library, this is where this is for the end user who's going to be a developer. But this is where you want to see how do I want to use this, and then you can develop it all from there. This isn't a Python talk, so we're not going to talk about Django. But what I want to talk about is frameworks. This is a big question for a lot of people. Probably a lot of us are building web applications and we're using web application frameworks. So the question is, how do I make a client library for my framework? This is my response. Don't. The framework is built in the language, and you want to create the client library kind of just in that language, and then use it through the web application framework. So it looks like this. This is not a moon here. We've got the core library, and then Meetup framework is related just a wrapper around that. So another example, just a model here, and it has a method here to sync it to the API, and we just call the client library that we put in elsewhere. And
Can you repeat what you said? What is your point there?
Oh, that so this is something I've seen where people are creating some sort of library. Really, they want to use it in an application framework. Maybe it's Django, Rails, and write something really specific to that framework. And in most cases, I think that's the wrong approach. So it's Python Red, Python package, or Ruby, or Gem. That is framework enough. Knows nothing about the web framework. And then from there, you in your own code, you can just use it directly, or write a separate package, or even kind of a separate module in that package to interface with the framework. But by and large, keeping it distinct.
Can you elaborate why?
Yes. One of the reasons why, and this is kind of a selfish reason, but other people might want to use it who aren't using that framework. So you've basically told a whole bunch of users, you know what, I don't care. This is 98% of the way there to making something you could have used, but now you can't. I found testing, it's much simpler to just test it without having to deal with the framework there.
So can I ask a question? So for instance, say somebody uses AngularJS to access an API. Are you saying that it's better not to use the AngularJS resources and all that stuff, do something separate?
I would say most likely what you can do is have your JavaScript library. It's a client library that can pull the data in. It doesn't need to know about what, how you want to use it, what framework you want to use it in. So you can use it with Angular or React or whatever you want to use at that point, or Backbone. And at that point, if you need to, you can have a separate module that can be the interface that can use those resources. And so maybe that means that your code is like 5%, 5% more code because you've got to get this extra step. But you're able to just test this one piece without having to invoke the framework. So, does that make sense?
I don't know.
Disagree, but
I think I understand your point. I'm not sure.
The whole point of the framework is you want to say
So in the case of, let's say, I wrote a lot of Django applications, so I do a lot of Python development. And if what I wanted to do was basically have some model, and I want to sync it to an API. This represents a resource there. That should be a very simple example. And let's say it's the Facebook API. That's what we're talking about. I'm gonna find it better in this case to have a Python library that doesn't know anything about Django, that can connect to the Facebook API, that can take whatever data I give it and give me the data back. And then when I want to use that in the Django application, it might just be a separate module. It could be the same. I want to make sure I'm using terminology, but the same package. And all it does is says, you know what, here's my mixin. I can add mixin class. I can add to a model, and it does that work. So it could be in the same package, but at the very least, that should be kind of an extra layer around it. And at the very least, I found that to be in code I've worked with and written just to be you're going to have a better time. Your mileage may vary, but
I think it probably depends on the language too.
likely.
Yeah, I was just going to agree with the point when you were saying. I think JavaScript is like a hard example because whenever you do API requests, you're doing it. In pure JavaScript, you're doing the XML HTTP requests, and they get really loaded. So maybe that's like a hard example. But if you think of if you use WordPress or you use Joomla or something like that, you rather write your library in PHP and create a little wrapper to plug into that framework. I think it's kind of what he's saying. It's just if it's easy enough almost to write it in that language natively. But yeah, Angular is a hard thing because you get so much out of it.
But I would
Or jQuery idea.
Yeah. I've just found that a lot of the testing is just a little bit extra and unnecessary. Why do I have to build the entire framework just to test this, which should be simple?
I think it's a general principle.
And again, this is not the right way. I can go back to that slide. This is some good ideas. And so this topic should be close to this next talk. So John gave a talk last month about API documentation and contracts. And we talked a little bit about this DSL-driven documentation where you're going to be able to actually develop some code from this. And we're talking about here being able to automatically generate matching client code. So here's a little bit of Swagger. This is one of their examples. Basically, you can without rehashing the concept, you can write this code, it's YAML, and describe the API. It's going to create this really detailed documentation. What you can do with this, there's a few tools out there, including Swagger Code, and what I found recently was Ramble Client Generator, is actually generate client code in one of the given supported languages or write it yourself that matches that based on that documentation. So you feed it. Here's this Ramble file, which is again the kind of one form of documentation, and generate the client in one of several libraries. So Swagger Code Gen lets you generate like PHP, Python, Ruby, Java. It's kind of cool. You don't really have to do anything. I'm going to talk about this in hypothetical practice, because what I did was read through the code, the generated code. I not had the opportunity to work with a lot of APIs that are documented like this, especially on a daily basis, so I didn't have a working example, and I was not sufficiently motivated to go and spend a weekend doing this. But one thing I noticed about the code is that you're generating from templates that are provided, and you generate it based on basically a whole set of opinions that come from the code generating tool. So one of the things I would talk about if I was saying, what are some things of value in a client library? Obviously, I want it to be tested. I wanted to handle errors well. I also wanted to be idiomatic. And so that was one of the things I found that, as impressive as these tools were, I didn't see that they weren't creating idiomatic code for the languages I was looking at, Python specifically. And that could be anything from naming conventions to how they're creating classes. You have some control over that with these language templates, but only to a small degree. So I think it's useful if you are the owner of an API and you have your documentation and you want to support kind of out of the box a set of languages. Then this is a useful tool. You're going to get clients people can use. If what you're really trying to do is create an API client for yourself, or that is going to be so popular, I'm not sure this is at least right now, the go-to tool. Again, it's creating the clients, but I don't think we've had an easy bake oven products. They are super easy, but they're not that tasty. So it's worth taking a look at. But again, I think really ideal if you're an API owner. And if you're not, I would consider doing the old artisan way. So that's what I've got. And if you guys have any questions, I'll answer them. If they're in anger, now I'll answer those too.